Okay, in today's videos we'll be taking a calculation problem on dimension. And as you can see, I'll be taking a problem number 1.2, and we are asked to write down the dimension of the following quantities. So we'll start with 1.2a, and the first one there is work. First, you must know the formula for the physical quantities that you want to find the dimension. That's number one. Number two, you must also know that the dimensional quantities we use are mass, length, and time. And dimensionally, mass is capital letter M, and the length is capital letter L, that is the initial, and then times capital letter T. Alright, so formula for work is force times distance. And the dimension for force is M L T minus 2, which is mass times acceleration. This is dimension for acceleration. Then times distance is L dimensionally. So if you multiply, you are going to get M L square T minus 2. That's the dimension for work. Number two, dimension for impulse. Dimension for impulse, formula for impulse could be force times time or mass times acceleration, because impulse is equal to changing momentum. So if we have this become mlt minus 2 times t. So if you multiply using your indices, minus 2 plus invisible 1 here give us minus 1. So we end up having mlt minus 1. Okay, that is question number B. Then C, we have density. Density, as we all know, is given as mass over what? Velocity. Mass divided by velocity. And dimension for mass is capital letter M. Dimension for volume is L cube, that is length times breadth times height. So length, breadth, height, they are all LL, which is L cube. So we'll end up having M L raised by minus 3. When you take this off, you change to minus 3. Alright, then D, we have coefficient of viscosity. Coefficient of viscosity is given as, the formula is Fx all over AV, where F is the force and X is the distance, then A is the area, surface area, and then V is the terminal speed. Okay, like you having an object, a container like this, and then you have some liquids. Okay, then release a stone into it, and then you want to look at the time at which the stone will reach the bottom, the base of this container. So what affects that movement, which is the friction in fluid, is what we call viscosity. So the coefficient of viscosity is given as the force, which is also called the drag force or the viscous force, and X is the distance, the height from the surface of the liquid to the bottom of the container. Then A is the surface area of that container or that liquid. Then V is the terminal speed, the speed at which this thing, the object, drops to the base. So if you put a dimension of each of these, we are going to have mlt minus 2 for our force times our L for distance, divided by area, which is L square, times the speed, which is LT minus 1. So we do that, you do your basic arithmetics. So do your basic arithmetic, so you end up having, multiply this by this, you get ml square t minus 2 all over, and multiply this by this, you are going to get L cube. Okay, L cube t minus 1. Now we have L here, we have L this way, we have T here, we have T. So we are going to make them to become a single L and a single T. So we end up having our M being constant, then L square, the 3 will come up to change to minus 3 using indices or the law of division. Then the T here, we have minus 2. If we bring it to change to plus 1. Okay, so we have this. So we are going to have ML raised by minus 1. 2 minus 3 is minus 1. Then times minus 2 plus 1 will give us minus 1. So we have this up there. All right, so this is the first three questions we have here. That is dimension for work, dimension for power, dimension for impulse, dimension for density, dimension for coefficient of viscosity. So in order to minimize space, permit me to use this way. All right, just get the solvings and the process taken. Just know the formula for each of these things, and I think you are good to go with that. So E is power. Now power is work over time, or energy expended per unit time. So if we say work all over time, sorry for that, we say work all over time, then the dimension I've already gotten here for work, which is ml squared t minus 2, can be imported here, ml squared t minus 2, then divided by time, which is capital T. All right, now the t here can become 1 by saying ml squared t, there's invisible 1 here, so minus 2 minus 1, I'll have minus 3, because this 1 has to come up to make it a single t. So that is that. So the last one but not the least is modulus of elasticity, which is F. Modulus of elasticity is our last problem here, which is F. So I have here modulus of elasticity, which is E equals to stress all over what? Strain. And of course, this is the Young modulus solution. So you don't need to fail these parts. It's very, very important. So pay 100% attention as I delve into Young modulus dimension. All right, so we have here as our stress is force over area, okay, while our strain does not have dimension because it is what? Extension all over original length, which is E all over L. So length will cancel length in terms of dimension, so that is off. So the strain has a dimension or has a value of 1, so that means it's dimensionless, since a constant is dimensionless. So I'm going to have here as E equals to F over A, meaning that the dimension and the unit of stress is the same with the dimension and the unit for what? Young modulus of elasticity. So in doing that, I'm going to be left with F over A. All right, sorry. So my F over A, my F has already gotten before now to be M L T minus 2, and then the area is L square. So by indices, I'm going to have M L T minus 1, meaning I'm taking this up. If we take this up, we are going to get 1 minus 2. That will be minus 1. So that will give us, and that will be multiplied by T minus 2. Alright, so these are the dimensional problems, and more examples are coming up soon. This is just few derived quantities have been able to get their dimension to solve this very problem. So more questions and more problems are coming up as students bring them up. So you are free to drop your question in the comment section regarding dimension, and there are other aspects of dimension I'm going to solve. So if you love these solutions, please subscribe to my YouTube channel. Hit the subscribe button. Follow me on Instagram, on the Twitter, and also on Facebook. Please don't forget to turn on the notification button, so that bell, so that anytime I drop my video, you'll be able to get them. I wish you the best. Stay safe.